Welcome to Radio VTV.
I'm Dr. Adriana Costa.
I'm DJ Dynamite.
The four elements of Radio VTV are science, art, music, and charity.
Do you remember the last show when we had Dr. Chris O'Grady talk about particle accelerators?
Of course, that was great. I learned so much.
So the fun fact for the week was that Chris has a band called Vertacyn Arc Materializer. Would you like to learn more?
Absolutely.
Do you remember the magic words?
Please and thank you.
Maybe the other magic words? Azeroth, Metreon, Zinthos.
It doesn't want me and I can't afford a ticket on the jet, let it out. I got myself a new suit with takes for hair and water, tasty food that keeps me safe and sound.
thought it was cheesiest.
Well, that was a trip.
This show we start with the art and check out the illustrations of Benjamin Ahn.
For science, Professor Dynamite McGillacutty explores chemistry with Dr. Alice Wheeler.
We go check out a show by Pinoles at the historic Ivy Room.
I love their drummer.
Me too.
For charity, we talk with Mary Spicer about the upcoming Oakland coastal cleanup.
All this and more music by Vertacyn Arc Materializer.
Hit them with the theme song, Dynamite.
You are watching Radio VTV.
This is Radio VTV. I'm your host, DJ Dynamite. Tonight I am joined with Benjamin Ahn. How are you?
Pretty good, man. How you doing?
I'm doing really great. So I've been a big fan of your work. We've teamed up a bunch of times at the Dr. Sketchies event, and I was always amazed at how quick you were able to put together something so cool. And your use of colors, and even your use of post colors, is very unique. But then when you go and look at your actual art, not saying that that's not your actual art, but stuff you really work on, it's amazing. So I just wanted to talk to you a little bit. What is your process for when you're making a painting?
Well, it changes. I feel like as time has gone on, I've developed different styles depending upon what I'm doing. So in the spectrum of where you know me from with Dr. Sketchies, where it's live drawing, anywhere from 2 to 20, 30-minute poses. I started with live drawing being very traditional, the whole newsprint and charcoal, going for, complete accuracy and everything like that. But then when I start doing Dr. Sketchies, I realized I had to really change how I approach a drawing. A lot of it, my style now has been garnered from, seeing how other people approach things, trying to create a little bit more rhythm and, fun to the drawing. I used to be very monochromatic. And now I approach it with a sense of very much letting go of ego. So I go in with more color, more, just a free-flowing line. I can still, map out an anatomically correct, drawing, but when it comes to these, shorter poses, more costumes, bar or event lighting, I had to change what I was used to doing. So I eventually started getting into pre-toning my pages with, splashes of watercolor, getting some texture in there, and allowing that to inform my drawing, which more often than not is mostly line work with little more hints of color or shadow. But yeah, just letting myself a little bit more free to explore, what that model is posing, the rhythm of the line, approach it with a little bit more fun, to be quite honest, so that I stay in practice of depicting the human figure, but doing it in a way that doesn't hold me back as much as it used to. It used to be very, very fine point, very, breathing into my lines, almost like a meditative process, but by the end of a pose, I had maybe the structure. Now I'm going more fully in, but that's one style of drawing. I do sometimes what I call bar sketches, where it's usually portraiture based, but the idea is that I at least start it at a bar or something like that, just casually drawing, and then I let it evolve. Sometimes it's very straightforward, mostly just ballpoint and maybe some ink. And then sometimes it'll be like, you know what, I'm going to throw some graphic elements of, bold lettering or, some design aspects, which is then different from how I approach a finish, like what I would call more of a finished piece, like something for a gallery or a commission. I still use elements, definitely a lot of the same media as far as like, ink and watercolor. But I will approach it with a little bit more care, planning out pre-sketches and ideas of like how I'm going to approach the piece. And a lot of times I don't know what I'm doing when I begin it. It'll, as I'm working through the piece, maybe there's a theme that's present, or a feeling that'll become more prevalent. Maybe a color palette that I was not originally intending to do, but I felt, through working in the piece, was appropriate. And then sometimes it'll be like, okay, I start with a drawing and now I end up with a drawing, painting / sculpture / carving. It takes on many forms.
So where can people go to find more of your art?
Well, right now I don't have any work up in any galleries at the moment. But
I mean online. Like you got the Instagram gallery and the Facebook
so
one.
if you want to find any of my work online, I would go to Instagram. My handle is Iorizu. I can't even pronounce it because it's a made-up word, but Iorizo. It's IORYUZO, which is the name of a character I started developing in probably middle school, and then I've continued to draw throughout the years.
All right, I'll make sure I'll spell it for everybody to see it. But thank you so much for taking the time to meet with us, Ben. I really appreciate it.
My pleasure.
I love his line work. Fun fact,
Ben has a gold tooth.
would you like to learn more?
Go to Instagram.com/Yoryuzo.
And now a word from our sponsor. What was that?
Thank you to Blammo and Log for sponsoring Radio VTV.
Did they pay for that?
They pay per view of the commercial, and I have to show them the analytics. That's why I put it near the beginning.
Are they selling a log?
I think they're using me to get people used to the idea of buying log, and when they eventually buy a log themselves, they'll buy the log by Blammo because it's the best.
Up next, Professor Dynamat McGillacutty explores chemistry with Dr. Alex Wheeler.
I'm your host, DJ Dynamat, and I am joined today with Dr. Alex Wheeler, and we are going to be discussing chemistry.
Nice to be here today, Matt. Thanks for having me.
It's so great to have you back.
Yeah, so my name is Alex Wheeler, and I did my PhD in chemistry with T. Don Tilley at UC Berkeley. And I'm here to talk about some of my research today.
Super cool.
And so I guess before that, so I am a synthetic inorganic chemist, and what that basically means is that synthetic chemists make molecules, and inorganic chemists like to study the non-carbon parts of those molecules. And so we're broadly interested in a lot of things, but enzyme active sites, materials, new catalysts. Those are all things that really excite us. And so in my PhD, we were really motivated to study water oxidation catalysts. And so catalysts are things that make a reaction easier, and you can typically recover them at the end of a reaction. And water oxidation is one half of the reaction to split water into oxygen gas and hydrogen gas. And that would be great if we could do really easily because hydrogen is a fuel, and then we could harvest that and get it from water, which would make a cheap, abundant fuel.
Now, are we talking water electrolysis?
Exactly. Yeah, so we like to think about that as two reactions. One where you take those oxygen atoms and you form oxygen gas, and the other where you take the hydrogen atoms and add some electrons that you got from the oxygen and you make hydrogen gas. So it's easier for us to break up those two steps when we're trying to do it industrially. And so the current state-of-the-art catalysts are all made with really expensive metals like ruthenium and iridium, and it's just not very cost-effective. But the best catalyst in the world is actually found in all plants in photosystem 2, and it's this cube-like cluster of manganese, oxygen atoms, and one calcium atom. And one of these manganese atoms is hanging off to the side, and the rest are in this cube arrangement.
Just floating out there.
It's just floating out there. It's called the dangler, actually. Yeah, someone had a sense of humor. And so, for my PhD, we were interested in studying a class of molecules that looked really similar. And the cool thing is that they were one of only, so I studied cobalt oxocubanes in my PhD. So, cobalt, oxygen, shaped like a cube. So I have a little model here of something similar, and you can see it's got these red oxygen atoms and then alternating metal atoms at every other site. So it's got 4 of each, and it forms this nice cube. And the cool thing is that it's one of only 3 cubes that is known to do water oxidation. So there aren't very many of these things that do anything like that.
And this naturally occurred.
So this was discovered, I believe, in the 1990s, but no one had really followed up on it much until the research group I joined did some further investigations and really probed the system.
Because it's a cube, that's a unique structure.
It is a unique structure. As to be clear, there are lots of people who looked into this thing before, but the group I worked in did a lot of the investigation of the water oxidation. And so I was really interested in, what about that dangler metal? How is that hanging out? What is it doing? And so I started to take this cube that we had and adding other metals to it. And we did find that you could form that kind of crazy structure that's found in nature with a couple of metals. But what was really interesting to us is when you take manganese, the metal that's found in nature, and you add it, it actually sort of boots one of the cobalt ions out. And so that was crazy to us because we had long thought this thing was pretty stable and you didn't really interfere with the cube structure all that much.
And it's not kicking out the dangler, it's kicking out part of the cube.
Yeah, exactly. And it's taking its place. So it's kind of like, get out of there, and then it moves on in. And so we thought that was really cool. And we did a lot of investigating.
So what were the metals that would replace that? Manganese? It's manganese that's already in there.
Yeah, so we found that when you add manganese to this all-cobalt cluster, that manganese ion that you added, that wasn't bound to anything before, would then kick one of the cobalts out from the cube, and then take its place.
Oh, wow. Okay.
Yeah, and so we were really interested in how did that happen, and we did all this stuff, and we suggested that it probably goes through something that looks like a dangler, something that looks like what's found in nature. And so we think that could be, maybe this is just like something that all of these cubes do. And so we were looking to prove, or really just show, could that happen with any other metals? And so I threw basically the whole kitchen sink, the whole periodic table at this cube, and we found that you can replace another cobalt, or you can replace a cobalt ion with vanadium or titanium as well, if you have the right conditions. And so that was also, it was just really cool to be able to show, oh look, we found this one system with manganese, and then actually extend it over to vanadium and titanium. And that was pretty much the summary of my whole PhD, really, was...
Super cool. Finding out that you could replace it with a different...
Exactly.
So, Did you notice different properties once you put the titanium in?
Oh, absolutely. It completely changes the properties. It was really interesting because previously when we would put other metals, there are a couple of other ones that had, so with the manganese, for example, that manganese site becomes the reactive site. So it used to be that with manganese in there, you could reliably do chemistry at just that one manganese ion. But now when you put vanadium in or titanium in, for the most part, you're changing the reactivity of the whole system. And what we found is that actually now you favor the reacting at cube sites that belong to the cobalts mostly. And so that was really interesting as well, was to see that we could sort of invert what we had previously observed. Yeah, and then the other exciting thing is that, at least in theory, vanadium cobalt oxide materials, when you take mixtures of vanadium and cobalt, those are pretty good water oxidation catalysts a lot of the time. So in theory, the material that I prepared could be used to study those materials because no one had really come up with a firm reason for why those were good.
Interesting. So now, by replacing that, will that help with the water electrolysis?
That's the hope, yes. We did not test that. We were really interested in just studying the rest of the properties, but
That'll be the next PhD candidate.
it's definitely, yeah.
That is so cool. All right, I'm gonna bring the molecule up a little closer to the camera so everyone can see how amazing this is, and we'll see if we can get maybe a
I'll provide some
illustration pop up.
drawings.
And then can we put your dissertation in the link?
Yeah, I can link to the papers. My dissertation isn't publicly available just yet, but I can share the papers for sure.
Oh, awesome.
Yeah.
Well, thank you so much for taking the time to teach us about this today.
Yeah, thank you for having me. It's been a real pleasure.
Yeah, it's pretty awesome. I really appreciate it.
Thank you.
All right, back to you, Dynamite.
I learned so much about chemistry I hadn't thought of. Fun fact?
Alex grew his own crystals with a molecule he designed. And bonus fun fact, he helped me rescue a scared kitty cat out of a tree.
Oh, what a wonderful person.
Now a word from our sponsor.
Thank you to the handsome chums of MHA for sponsoring Radio VTV.
Let's go check Pinoles play a show at the Ivy Room.
Treat you unfair. It's been a while since I was alright. Oh yeah, I wonder if she's there at all. Sit around acting like I don't care. Oh yeah, 'cause I know tonight you'll have a ball. I'll dream of her at night. Won't make it the last time. Can't get her out of my head again. Baby, play my audio. Baby, I'll drink you again. One thing that I know for sure, music is the only cure.
That was a fun show. Fun fact.
Manny D of Pinoles plays drums on the Radio V theme song.
Would you like to learn more?
Go to thepinoles.bandcamp.com.
And now a word from our sponsor.
I always thought that I learned colors wrong, but as I grew older, that's when the doctor confirmed that I was colorblind. So today, we're opening up these glasses that my dad bought for me for my birthday. They're made by a company called Chroma. Such a difference.
They worked!
Thank you, Chroma, for sponsoring Radio VTV.
Indeed. Let's talk with Mary Spicer about the upcoming cleanup in Oakland.
Tonight on Radio VTV, we are joined by Mary Spicer, one of the organizers of the Alameda Estuary Cleanup. How are you, Mary?
I'm great. I'm so happy to be here. It's really good to connect.
So I got to participate in last year's cleanup, and it was interesting because we had us on the beach. There was quite a bit of us, maybe like 50, and then there were people in kayaks with little scoopy nets. So we didn't just clean up the beach, we cleaned up the actual waterway, which was pretty cool. And I think we got over 3 tons. So
Yeah, it is a pretty wild ride. There's so much different areas. Oakland Estuary is really a beautiful waterway, and what's so unique about our little estuary is that it does have beaches, and it has a few beaches where we can actually kayak to and land our kayaks and get off the kayaks and collect tons and tons of garbage. Just the same way that we like to land on the shoreline, the garbage from all the storms and the lack of storm drain catchment likes to come up through the Lake Merritt Channel and flow right out and land on all of the beaches as well. So the area right near the Lake Merritt Channel really does have a great deal of garbage and marine debris, a lot of sunk boats, smash boats, a lot of piers and logs that come down. So when we do our really fun adventure cleanups, I like to call them adventures, we have a land crew that just deals with the Jack London Aquatic Center park garbage and the shoreline there, as well as the Bay Trail shoreline.
Oh, wow.
Garbage. But then we hop on our kayaks, our stand-up paddles, and our canoes, and we paddle off to the beaches and we land. And we have 6 sites right in the Jack London Aquatic Center area where kayakers can paddle to and land, and our guides will lead mini cleanups on each beach. And then we partner with East Bay Row Club, which is a public rowing club, and they're amazing, and they're out of Jack London as well. And they bring besides bringing their team to come out and clean, they also they donate their skiffs with us, and they will come and pick up all the garbage that we clear from the beaches, which otherwise we wouldn't be able to clear it from the shore because we couldn't really paddle back that much garbage.
Oh, wow.
So it's really an amazing adventure.
That is so cool. So how did you start all this?
In 2016, we're coming up on 10 years, which is really amazing. I used to, I stand-up paddle, have stand-up paddle for years and stand-up paddle race for years. And I also was on a dragon boat team out of Jack London Aquatic Center, and just every practice that we would be out, I would be so disheartened, as well as my other team members would be completely disheartened by the ducks that we saw having their nests in garbage and squalor, and just pounds and pounds of garbage just never really being cleared. A group of friends, aquatic athletes, a whole bunch of stand-up paddlers and dragon boaters, we just got together out of Grand Street in Oakland and hopped on our paddle boards and just started going to the beaches and the rocky areas that you can't walk to. And eventually we just got so much garbage that day, we were blown away. So after that, I just started inviting my aquatic people that love the water and are on it and see the garbage day in, day out. And I think when you're on the shore, you don't see the amount of garbage that's on the shoreline when you're out on the water. And I think that if anybody saw that, they would be motivated to join us, because it really is, I think we have I think it's our job to actually protect nature, protect wildlife. Especially when I think cities are overwhelmed, and I think that as we evolve, or as humans, as we're evolving, I really think it's our work to actually take care of the earth and take care of nature. So
Definitely.
It started like that, and it grew into a community group, and now we're a full-on nonprofit.
So cool. So where can people go to find out how to get involved?
So I have a website. If you just type in the words I Heart Oakland, Alameda Estuary.com, you will find our website, I Heart Oakland, Alameda Estuary.com.
Cool.
It's a little long, but
it gets you right there.
Yeah, it'll get you there, and then it's going to be November 9th. And to sign up for that, just go to supkayak.eventbrite.com.
Oh, perfect. Well, thank you so much.
Yeah, that'll take you right to the sign up.
I really appreciate you taking the time to speak with us tonight about this. It's a great effort, and it's awesome that you're doing it.
Thank you so much.
That looks like fun. I hope to go sometime. Fun fact.
The cleanup was right by Merchants, which is like the perfect way to end a cleanup.
That was a fun show.
It goes fast.
We want to thank Blog by Blammo, MHA, and Enchroma for the show sponsorship.
And thank you to Cece for your help in the science department.
Thanks to Dr. Sketchies and 111 Mena for help with Benjamin Ahn.
And thank you to Manny D of Pinoles for that awesome footage.
How did he play drums and film himself at the same time?
That's Manny D. He can do anything he sets his mind to. Thank you to Mary Spicer and to Alina for the Alameda Estuary cleanup.
Thank you to everybody who came back after the first show. You are most welcome here.
And thank you to everybody who watched for the first time.
Let's hear another Vertacyn Arc Materializer song.
A very fine line to cross. Alpino, weight loss. You need a mattress. You genetically quick. Fold it again until it just doesn't exist. Pulmonary disease. Sleep deprivation, neurotransmitter activation, pretty please. So move your shit, Mr. Wilson. Move your shit, Mr. Heath. Come take a look at the silver sparkle shining underneath.
Was that at the secret practice bunker?
Next week we have a show featuring music theory
Music by Tell Me.
and art by Matt Luning.
I heard there's a mystery about the charity, something to do with bees, Hermes, and alchemy?
The story behind that one's intense. I'm so excited for the next show.
Hit them with the outro, Dynamat.
You watch that radio, VTV.